topic of a lecture is the Fourier series. We have already started the topic of Fourier series in our class, and we have stated what is a Fourier series and what is the Euler formula for finding out the Fourier series with the help of Euler constants. One more example to clarify how to find out the Fourier series. I am going to start with one more example today. The topic is Fourier series. We have already stated to you. Fourier series is there. Now, let us do one more example. Find out the Fourier series for the function x sine x in the period 2 pi, or the range of the function is 0 to 2 pi. So if the range is a complete 2 pi, then clearly it is the question of a full range. So you have to apply the formula of finding out the Fourier series. The Fourier series is f of x is equal to a naught by 2 summation n1 to infinity a n cos of nx plus bn sine of nx, and name it as equation number 1. We shall find out the Euler constants a0, an and bn. These are the Euler constants which we need to find out. And after finding out these Euler constants, we will substitute the values of a0, an and bn in this equation number 1. I'll get the final Fourier series. Let us find out the first Euler constant. The formula of finding the first Euler constant is 1 upon pi 0 to 2 pi f of x dx, and that is also 1 upon pi, that is 0 to 2 pi function. The function is x sine x dx. Now you just need to integrate this function. So clearly in this function x can be taken as a first function and the sine x can be taken as second function, and you have to integrate this by parts. First function, as it is integral of sine minus cos, that is the limits are 0 to 2 pi, again minus 0 to 2 pi, derivative of first function, that is 1, and integral of sine is minus cos dx. Now you can substitute the limits here. When you substitute upper limit, that come out to be minus 2 pi cos 2 pi and cos 2 pi, and for lower limit that will be the positive sign, because here already negative sign is there, and for lower limit 0, 0 into cos 0 comes out to be 0. So minus and minus is plus, integration of cos x is sin x, and the limits are 0 to 2. Now, if you substitute upper limit here, sin 2 pi comes out to be 0, because sin all multiples of pi are 0, and for lower limit 0, this is also 0. Sin 0 is 0. Now, you just see, cos 2 pi is plus positive 1, and the pi can be cancelled with this pi. Ultimately, it comes out to be minus 2. So this is the value of a first Euler constant. Now we can also find out the value of a second Euler constant, that is an 1 upon pi 0 to 2 pi f of x into cos of nx dx. 1 upon pi 0 to 2 pi f of x is x sine x into cos of nx dx. You can multiply it with the 2 and divide by 2 just to make the integration easier, but it come out to be 1 upon pi 2 pi, that is 0 to 2 pi. Now you can apply the formula of 2 cos a sine b, and the formula is sine of a plus b minus sine of a minus b. Now you can integrate, first of all, you can make separate integrals so that you can integrate it. X sine of n plus 1 x dx and minus 1 upon 2 pi 0 to 2 pi x sine of n minus 1 x dx. Now you can integrate this integral by parts. 1 upon 2 pi, first function x as it is, integral of sine is minus cos of n plus 1 x divided by n plus 1, and the limits are 0 to 2 pi minus the derivative of x is 1 and integral of sine is minus cos, so minus cos of n plus 1 x over n plus 1 dx within the limits 0 to 2. So this is the integration of first term. Similarly, we can integrate the second term also, and the second term is first function as it is, this one. Integration of sine is minus cos n minus 1 x over n minus 1. Limits are 0 to 2 pi minus 0 to 2 pi. Derivative of x comes out to be 1, and integration of sine comes out to be minus cos of n minus 1 x upon n minus 1 dx. Remember, the limits in this question are 0 to 2 pi. You just see, because this is the interval in which we have to find out the value of the Fourier series. Now you will substitute the limits. You have to make some space on the left hand side. I am going to erase the value of a naught. Remember, the value comes out as minus 2. We should substitute at the last of the question, equation number 1. Let us find out the value of an. An comes out to be 1 upon 2 pi. When you substitute 2 pi here, what it come out to be minus x cos of n plus 1 into 2 pi upon n plus 1. And when you substitute 0 here, 0 into cos of 0 come out to be 0. And what is this? This is minus and minus plus, and cos. Integration of cos is sine. So it come out to be sine of comes out to be sine of n plus 1 x over n plus 1. Even n plus 1 square, because n plus 1 is already there. So there will be n plus 1 square. So limits are 0 to 2 pi, and this is the first term. Similarly, we can find out the second term also. In place of x, we also have to substitute 2 pi. So it should be 2 pi, not x now. So this will be 2 pi. And for second term, we have minus 2 pi cos of n minus 1 into 2 pi upon n minus 1. For lower limit 0, it come out to be 0, and minus and minus is plus this one, and integration of cos come out to be sine. So what it come out to be? Plus sine n minus 1 x upon n minus 1 square. Because 1 n minus 1 is already there within the limits 0 to 2 pi. Close the bracket. Now let us solve 1 upon 2 pi. Just understand this. We have to apply the de Moivre's theorem as we have stated in the previous class, that cos of 2 pi comes out to be plus 1. There is a n plus 1. So what will you get? You will find out the value accordingly, because this is a cos of 2 pi, and that will be 1 par cos 2 pi is plus 1, and that will be 1 par n plus 1, and 1 par n plus 1 is same as this come out to be 2 pi 1 par n plus 1. This is with the help of de Moivre's theorem. And for this term, that is sine, when you substitute upper limit 2 pi here, sine all multiple of pi are 0, and for lower limit 0, sine 0 is also 0. So this term will vanish. It means this term will not give any value. Similarly, this one, this term will also not give any value. From this term, you will get a minus, and minus comes out to be plus value, and here is a negative sign. So this is plus 1 upon 2 pi into 2 pi, and on the same pattern, by de Moivre's theorem, cos of 2 pi is plus 1, and that will be angle. Angle coefficient of the angle is n minus 1, and that will be on the power of 1. 1 raised to power n minus 1 over n minus 1. But 1 raised to power n minus 1 and 1 raised to power n plus 1, whether n plus 1 is even quantity or odd quantity, it will give as 1. So there is no need to take a power n plus 1 here. 2 pi is cancelled. It is come out to be minus 1 over n plus 1. Similarly, 2 pi is cancelled, and 1 raised to power n minus 1. Whether it is even or odd quantity, it will give us plus 1 upon n minus 1. Now, you can take the LCM of it, and what it come out to be 2 upon n square minus 1. And just understand, this value does not exist for n is equal to 1. Because if you substitute n equal to 1 here, you will get a 0 in the denominator. You will get an infinite value of this a n. One more thing is there, for n is equal to minus 1 does not exist. But we need not to discuss this case, because our range in the summation is n1 to infinity, not n minus 1 to infinity. So that's why we have to particularly mention that this value does not exist for n equal to 1. Now, what does it mean? It means we need to find out the value of an for n equal to 1 separately. So for this, we have to find out the value for the particular case as n equal to 1. Let us find out here. For n equal to 1, what will you get? You will get a1, 1 upon pi 0 to 2, 0 to 2 pi upper limit, and the function is x sin x, and there should be cos nx, but in place of n we are taking 1, so that will be cos of x dx. So what you need to do, you need to divide it by 2 over here, and you have to take 2 here, just to make a trigonometric formula so that we can easily do the integration. This come out to be 0 to 2 pi x sine 2x dx. Now you can integrate it by parts, but it come out to be make some space here. Let us do now integration by parts. This come out to be 1 upon 2 pi. First function x as it is, integration of sine a minus cos 2x upon 2. The limits are 0 to 2 pi. The derivative of x is 1 within the limits 0 to 2 pi, and integration of sine a minus cos 2x upon 2. Now you just substitute the limits 1 over 2 pi. When you substitute upper limit 2 pi here, you will get a minus 2 pi, and there is also cos 2 into 2 pi that come out to be 4 pi. So cos 4 pi is always plus 1 upon 2 is there. And for lower limit 0, cos 0 into 0 that come out to be 0. Minus and minus come out to be plus. Integration of cos come out to be sine 2x upon 2. 1 2 is already there, so that will be 4, 0 to 2 pi. But it come out to be for upper limit 2 pi. If you substitute upper limit, you will get sine 4 pi. Sine all multiple of pi are 0. For lower limit, sine 0 is 0. What you get? You will get this value vanish. 2 pi is cancelled, and you will get minus 1 by 2. So remember, for n equal to 1, the value of a1 is minus 1 by 2. So this is your value of en. The value of en is this 2 upon n square minus 1, and the value of a1 is minus 1 by 2. Remember, we shall substitute later on. Now, let us find out the important value of third Euler constant. The third Euler constant is and make some space over here. Create some space. Now, let us do. The value of a third Euler constant comes out to be Tn is 1 over pi 0 to 2 pi function into sine of nx dx. Now you just need to substitute the function 0 to 2 pi. The function is x sine x into sine of nx dx. You can multiply it with 2 and divide by 2 just to make the formula of 2 sine a sine b, so that we can do the integration easily. 1.2 pi 0 to 2 pi x. Now apply the formula of 2 sine a sine b, and that is cos of a minus b minus cos of a plus b dx. And you can write down two separate integrals, that is x cos of n minus 1 x dx minus 1 over 2 pi 0 to 2 pi x cos of n plus 1 x dx. So these are the two separate integrals which we shall solve now for finding out the value of third Euler constant. Now let us find out the integration over here. Now, first function x can be taken and cos n minus 1 will be taken as second function. So integration by parts, what it come out to be, first function as it is integration of cos is sine, that is sine n minus 1 x, and limits are 0 to 2 pi minus derivative of x is 1 and integration of cos is sine n minus 1 x over n minus 1 dx within the limits 0 to 2 pi. The next term is 1 upon 2 pi x. You will integrate this integral also by taking x as first function and cos n plus 1 as a second function. So x as it is, integral of cos is sine n plus 1 x dx over n plus 1 0 to 2 pi minus the derivative of x is 1 and integration of cos come out to be sine n plus 1 x dx over n plus 1 within the limits of 0 to 2 pi. Now, when you substitute the limit here, you just see when you substitute 2 pi here, sine all multiple of pi are 0. When you substitute 0 here, sine 0 is also 0. Ultimately, this term will vanish after substituting the limit. Similarly, this term will also vanish. When you substitute 2 pi, sine all multiple of pi are 0 and sine 0 is 0. You get that 1 upon 2 pi integrate sine again. That come out to be minus cos n minus 1 x upon n minus 1. N minus 1 is already there, so one more n minus 1 will give you n minus 1 square. Now you will substitute the limits 0 to 2 pi. Similarly, this is a minus and this is a minus. This come out to be plus. Integration of a sine is minus cos n plus 1 x over n plus 1 within the limits 0 to 2 pi. And outside there is 1 upon 2. So now you can substitute the value 1 upon 2 pi can be taken common. So what you will get when you substitute 2 pi over here, cos 2 pi again by using De Moivre's theorem, that is a plus 1 raised to power n minus 1 will always give you positive 1 as we have discussed in an. So it come out to minus 1 over n minus 1 square, and for lower limit 0, cos 0 is also 1, so it come out to be 1 over n minus 1 square. Now substitute the upper limit here, cos 2 pi into n plus 1. Again by De Moivre's theorem, cos 2 pi is plus 1 and raised to power n plus 1. Always give you 1. So that will be minus 1 upon this should be square. Because 1 already n plus 1 is there, and after integrating you will get 1 more n plus 1. So n plus 1 square. And similarly for cos 0, that is 1, and you will get n plus 1 square. Again, we'll see that we need to find one more thing. This value does not exist for n equal to 1. So this is possible for n not equal to 1 because when you substitute n equal to 1, you will get 0 in the denominator and you will get infinite value. So that is why it is not possible. And the same term is there with a negative and positive sign can be cancelled. This will also be cancelled. So this come out to be 0. It means the value of Bn comes out to be 0 for all n not equal to 1. It means n not equal to 1 के लिए तो you can also write down the condition like this that it is 0 for n equal to 2, 3, 4, so on. infinity. But for n equal to 1, we need to find out a special case, that is p1 on the same pattern of a n. So it is 1 upon pi 0 to 2 pi fx is x sine x, and there should be sine x, sine nx, but n is 1 in that case, so this is sine x dx. Now what it come out to be 0 to 2 pi, that is x sine square x dx. You just need to integrate it. After substituting the value of sine square, it is will be easier to integrate. So substitute the value, that is 1 minus cos 2x upon 2 minus cos 2x upon 2. Choose the formula of cos 2. Now you can easily integrate this term. Let us see. There is some space from the left hand side. Now let us do the integration. And integration comes out to be integral 1 out to be 1 on pi. Remember we are finding p1, that is 0 to 2 pi 1 by 2 x into dx minus 1 by pi 0 to 2 pi x cos of x dx. This is 1 by 2 pi x square upon 2. Substitute the limit 0 to 2 pi minus 1 by pi. Integration by parts. First function x can be taken as it is. Integration of cos 2x is sine 2x upon 2 0 to 2 pi minus, for lower limit, that is for the limits 0 to 2 pi, derivative of first function 1 and integration of cos is again sine 2x upon 2 dx. Now substitute the limit over here, that you will get 4 pi square upon 2, and for lower limit 0, that will be 0. This is when you substitute 2 pi over here, you will get sine all multiple of pi is 0. For lower limit 0, sine 0 is 0. This term will vanish. Ultimately, minus and minus will be plus. Pi and 2 is 2 pi. So 1 upon 2 pi, integration of sine is minus cos 2x over 2. Given the limits 0 to 2 pi. So 2 pi will be cancelled, and one more 2 will be cancelled. You will get pi from this term. Now you can get minus 1 over 4 pi. Substitute the upper limit 2 pi. So cos 4 pi will be here. Cos 4 pi is always plus 1. Cos 0 is always 1. So this term will also be vanished, only you will get 1. So this is your value of 1. This is the particular case of finding out the value of bn for n equal to 1. Remember, the value of bn was 0. So now you can substitute all these values in equation number 1. Now you just see, make some space. This was your equation number 1. Let us again write, that was Pn sine nx number 1. Now put the value fx is x sine x, and what was your a0? A0 comes out to be minus 2, and that is 2. This is 2 plus A1. The value of A1 was -1/2 and cos of x for n equal to 1, and for n equal to 2 to infinity, the value comes out to be 1 over n square minus 1 into cos of n x, and that was a 2 over, not 1 over. So this value comes out to be 2, comes out to 2 over n square minus 1. This is for n 2 to infinity. For n as n equal to 1, the value of b1 is pi. You just see this is pi. So pi sine x, and for n equal to 2 to infinity, the value is 0. So this is a ultimate series which we require, that is -1 minus 1 by 2x plus, this term can be written here, pi sine x plus, so open the series here. For n equal to 2 to infinity, 2 is common, that come out to be cos 2x upon 2 square minus 1, that come out to 3. So this is 3 plus cos, for n equal to 3, that is cos 3x upon 3 square minus 1. 9 minus 1 is 8. So this come out, this can be written 2 into 4, and 3 can be written 1 into 3. And similarly for n equal to 4, that is cos 4x, and that will be 4 square minus 1, 15. So that will be 3 into 5. This is the pattern we can easily make. So this is your required series. This is very important question. Make all the things clear in your mind. This question will give you uh, complete knowledge of the topic of Fourier series, that how to find out the Fourier series with the help of Taylor constant. I think all types of integration formulas and types of integration have been included in this question, which we require in the Fourier series. So that is why I have discussed this question here. So thank you very much. Thank you all.